On it.
Started the recording, and let's go over last week's notes. I have them open here. So last time, not last week, 2 weeks ago, we actually talked about the open pull request, which I saw is still open, but I think there are no objections left. I don't know, are there objections from our colleagues in Asia who have not attended the last meeting because of the time zone? Let me put the link quickly in the chat that you know what I'm talking about. Otherwise, I would just, there are no objections right now, I would just merge it and then we can change it afterwards. Are there any objections, or do you need some time to reflect on this?
I think it's silence golden or silence acceptance.
Yeah,
Anybody have an
sorry.
objection? I don't.
Okay, then I'm finalizing it, and then I would quickly share the notes from last time to give us some guidance to move forward. So 2 weeks ago, this should be, you see my screen now?
Yep, we see.
Awesome. So last time, 2 weeks ago, we talked about the MR, which is now done, or PR, it is in GitHub, and we noted, or actually did a topic collection of topics we want to focus on now that we have a good first idea of what we all understand with embedded. And first question would be to our colleagues again in Asia who have not attended the last meeting, if there's something missing. So so the points, let me quickly go over it. The points we were collecting and wanting to discuss in future is in general, I think these two belong together, what the limitations are for the component model for microcontrollers, or if it can fully be utilized in our what we call embedded in our target platforms, and what would be the implications using the canonical AVI. Should we start a push for a preview 3 in WASI and getting, especially in our interest, getting rid of malloc and realloc here. Also, an interesting point to follow from Christoph Petik is his investigation towards the Isorex like interface where we would have some kind of a pub/sub API between components and between component host system. How we would further develop the WOT for our targets. There need to be a discussion about threading, so how threading will be implemented and represented in embedded WASI. What to do with stack switching. So how can we handle signals. Here I'm a little bit lost. Is this about low-level interfaces like I2C SPI? I'm a little bit lost here.
I think this was about how do we map things that are written in WIT with components to run as modules.
Oh, right.
versus
Okay. Yeah.
because
Okay.
WAMR itself does not understand the component model and
Mm.
therefore can't do the imports and exports. But I think it was Luke a few weeks ago presented something about making WASI P2 module, I think, as a target. And so basically just unwraps the components and makes them standard modules.
Yeah.
Okay. And then
So
last,
any plan on
sorry,
that,
yeah, please.
Steven? So for the previous topic, so any plan for that? So still just the idea.
As far as I understand, Luke proposed it, and I believe some work has started in the WASI SDK to do that. But I tried using it a few weeks ago, couldn't get it to work because there's some things missing. Asked a few folks in one of the Discord channels, and they said it was still pending. So it's probably something to talk at the Bytecode Alliance call, which I think is this week. We can bring that up there. Do you want me to take an action item to? Oh, there's the. Yeah, somebody just put in the link.
That would be great. Thank you.
Okay, I'll add that to. I'll send a note to Bailey and add it to the agenda.
Do you, by any chance, have a link to this discussion at hand, or maybe we can put it in the notes then later on?
I'll put it in the notes.
Awesome.
I think it's confusingly named in as an issue in GitHub for the WASI SDK. So it's it took me a while. I'll find it again.
No. The question is, do you have it right now, or we will put it later on in the notes? Yeah. So
I'll try to put it in the notes.
Awesome. Thanks. Cool. Yeah. And then we talked about specific embedded specific interfaces stuff. So I know pretty quick and pretty maybe hard to follow summary of last meeting, but is there something missing in the future discussions? So is there? Do you feel there's a point not addressed here? Did we miss something in our last discussion?
To me, this seems quite comprehensive. So it's
awesome.
The desire to kill the malloc and realloc. Is this been a desire, or is this kind of pre-decision making? So I recall that Chris told something about it the last weeks.
Yeah. So if I get the facts straight, which is complicated on its own, I think there's an idea or discussion towards it. So there's no say definitive plan, as I understood, but
yeah, but data type transformation, etc. So kind of lifting and lowering is still to be done, right? So there was a discussion. I recall a discussion where it was in the room of possibilities. Let's call it that way. That if you can ensure that every WebAssembly module uses the very same ABI. So, for example, every WebAssembly module that is run by a WebAssembly runtime is programmed the very same language and uses the very same ABI, then there's no need for lifting and lowering. So you could omit that, and possibly you could also have some kind of shared heap, which is currently done in WAMR, so that you can just pass pointers around without having any copy. So that would be a truly zero copy. And you also would not have to worry about data types. Is this something that is still on the table to be discussed? I'm just recalling it a few months ago that there has been some discussions with Luke and with Bailey around that. Does anybody know something about it?
My notes on
I know there was some discussion around being able to share buffers and memory between WASI modules or between the runtime host and WebAssembly. That's useful for things like image capture, which I know friends at Sony want to do, or doing
Yeah,
sound or sensor.
Exactly. At least a read-only access. It's very useful.
Yeah, I think read only, but there's situations on our side, I think too, where we might have sensor data that's somewhat big, or largish, and we need to write to that. On one side we need to write, and the other side we need to read, and vice versa. So I think read only would be okay. I think we'd probably need read write. So I know there's that discussion. I think it was Christoph Pettig as well was talking about if we picked an encoding for things, we could then do this across languages, because you take a struct now and you put it into a buffer memory and then you read it on the other side in the same language, probably going to align okay, right? But if you're doing it from say C to Rust, those types don't generally match up, right? And even if you do, there's sometimes bytecode alignment and things like that. Byte alignment and buffering and things of that just don't make that line up. And so I think it was Christoph, was it 2 weeks ago, presented some way to encode that, or sorry, had some proposals for how we could decide upon a canonical encoding, and then that could be mapped to various different languages, allowing for that cross language compatibility. So those are the two discussions I remember.
Yeah, makes sense. Makes much sense. I think it's just inevitable, right? If you want to have interoperability between different languages, that you need some kind of canonical ABI, and you need this lifting and lowering. There's no way around it, right? Where when you're poking around with structs and with all the padding and alignment, etc., you need something like a unique type mapping.
Well, I think anybody else jump in, because I might have gotten this wrong, but I believe Christoph's proposal was to avoid lifting and lowering by saying, hey, this block of bytes that we're sharing across, this buffer of bytes that we're sharing across, has an encoding, right? And this is the encoding. And so if you're writing to it from C, you'd have to write to that encoding. If you're reading from it from say Rust or Go, you'd have to know how to decode that. And think of something like, I think one of the examples he was using was protobuf.
Yeah, got it.
Yeah, it pushes the responsibility for serialization, deserialization into each module, into the language specific part,
right?
Rather than having a canonical,
right,
encoding for all data structures that it's language independent.
Right.
Yeah.
If you the middleman, but then it makes every single one of the runtimes, required to understand every other possible, encoding that may come its way, right? So,
right,
it's the kind of peer-to-peer versus hub and spoke, right? In some sense, which is okay. It's fine. Yeah. We don't need to support like every possible thing on the planet. It's okay.
Yeah, got it.
Yeah, because if I understand correctly, the current proposals within WASI, WebAssembly, are to have the runtime do that. So the runtime is the one that's responsible for doing all that work and supporting that interoperability. And what Christoph presented was moving that to the modules themselves.
And in a sense, into the SDKs, right? So I mean, we're developing some SDK type stuff right now. It's exactly that. Like we will have take in an IDL of some sort, be it WIT or something else, and then the encoding and decoding has to match up. Obviously, the runtime doing it makes it much easier for the SDK developer, you know, at the cost of potentially doing unnecessary encodings and decodings, at least in one direction.
I think that's an interesting way to put it, Dan, because I was thinking this would be done by each of the modules, but you're right. It's done in the module, but it's actually done in the SDK, really. And then anybody running code doesn't have to do it.
The coder doesn't have to be aware of it necessarily, but what comes out of the compilation process includes the serialization.
Mm-hmm. Yeah. Do you know how the discussions are evolving? Is this already running? Or is there any feedback inside the community about this?
Actually, I don't know. I haven't joined the discussions.
Yeah, me neither. Have to. All right.
So
is there a next step or something that we need to do or take or do on that item? Because I feel like this one's kind of important to a lot of us. And I think if we want something to happen there, we probably to get a little bit more involved, at least a few of us.
Yeah, I just can tell from our side that the component model seems to be quite right from its ideas and visions, right? We want to achieve, but the implementation is in the current state of implementation is not in the state where we can use it at all. Because of maturity of toolings and the way it's implemented in terms in the meaning that it impacts the performance and memory fragmentation, etc. Right? So, and that's why if we want to use the component model in the future with the WIT descriptions, we need to have another implementation for it. Otherwise, it's quite likely that we would stick to WASI P1 and more POSIX-like interfacing, because that's the way it is, and a lot of modules outside in the world are already using WASI P1. So this is what I can from my side.
If I'm trying to take a lot of notes here. So if I'm correctly understanding you, Thomas, I think in principle, you like the design of the component model, but in reality, when you're dealing with the systems you have, the complexity that adds to the runtime and sort of the characteristics it adds prevents you from using that in your application, and you would stick to WASI P1. You would need to stick to WASI P1.
Right. That's the current state.
Okay.
As said, the component model itself and the description, what you're doing in a more or less language agnostic way, right? And to get interoperability, this is very, very valuable a property of the component model itself by design. And this is really great. You can use it nearly everywhere you want it to. However, we are in the situation where we need performance and very low footprints, and we need also shared memory, not only across WebAssembly modules, but also between host and WebAssembly module. And this shared memory must not be forced to sit on the heap of the embedding host. It can also sit on another side that is managed by any other application on the desired system. So performance kicks in, and that's why we need shared memory, and that's why we just cannot use any approach that's using a lot of mallocs, reallocs, or data conversion mechanics on each and every call that is to be done between different, let's say, parts of the software. That's just like it is. And we feel that the component model is just not in a state where it's usable for us because of those restrictions we have. That's why we are pushing quite hard, especially internally, but of course in parts also externally, to move on with it and to try to find a way to use the benefits of it, and on the other sides don't have the trade-off of giving performance, because that's just no way for us.
So you look like for a component model without copying and without malloc.
Right.
Mhm.
Right. And if the trade-off would be use the very same language in every and each WebAssembly module, or just use a fixed ABI, which is maybe a C ABI, then that would be a way to go.
No.
Yeah, I also feel there is a need for a simpler ABI, and component model can solve some needs, but there's also a need for simpler ABI between the modules.
Mhm.
And personally, I like something on top of the CABI because we can be much easier and
Yeah,
you can
at the end, the result is the important thing, right? If it, I personally do not care which ABI is used, but it must be in a way that it's performing very well by design. This is just this kind of trade-off is something that we are suffering if we would have to take it.
Yeah, that if you for some scenarios, maybe we only want to support the static kind of languages.
Mhm.
Yeah, the
Then
static type languages.
yeah,
Mhm.
then
That
CABI
I think
will
is
naturally
I think
fit.
that's a given. Static typing is I think is a given for our environment because we can make it like for example, we're very interested in Python, but we're going to mandate that it's statically typed, right? In our
Mhm.
SDK.
Yeah.
Yeah, makes sense.
Well, and if you need dynamic stuff, you could build something yourself on top of that if you truly needed that, right? You could pass a buffer
Yeah.
that's encoded, and you could have some tag that says it's this type of encoding, and then it would be additional work, but it doesn't preclude you from doing some sort of dynamic passing. It just wouldn't be automatically part of the ABI.
Yeah.
Yeah, maybe also if you have dynamic languages or or also languages that use exception handling, for example, performance is probably a trade-off you can take in some scenarios, right? So just imagine using exceptions in a real-time system. I think normally you won't do this, right? So, and the same holds for garbage collected languages. If you have a lot of garbage collection, you probably won't use it in a real-time system.
I think there's a fundamentally difference in the usage for kind of a cloud and embedded.
Right.
In the embedded, actually, the host is still playing a very important role. So a lot of design it will be in the host, and all the interface is carefully designed for the particular device. But for the cloud, actually, you want everything, every logic is running in WebAssembly. So, so the WebAssembly will be long run. I mean, for the host, pretty like just most of the time still running on the host, and just put the WebAssembly module as some plugin to handle some particular data or events. So from the usage, that means we more care about how host interact with the modules.
Yeah,
Mhm.
agree.
Yeah, definitely.
I think one thing that was discussed last time by Chris Woods was, you could do this in C, and I think we all, I think we're kind of saying that's an alternative, right? We could do this in using C encoding. The challenge there is things like byte alignment on certain structures and certain platforms and whatnot. And while WebAssembly would not be a problem because there could be a consistent alignment between those two, between the host and the module, that could be an issue, especially with different CPU architectures, different alignment, different memory, all those other challenges. So you wouldn't just be able to take a C struct and use that C struct on both sides of the thing. We'd probably have to have some limitations on that says, yes, it's the C struct, or yes, it's this kind of ABI, but it's limited to this with this alignment, et cetera, et cetera. Does that make sense?
Yeah.
Yeah.
Yeah. Yeah.
Yeah. So this will be the problem after all, the padding stuff here. I want to circle back to what Thomas said about garbage collected languages. So I fully agree that garbage collection and hard real time do not play well together. But did you really mean that we would then fully exclude all garbage collected languages, or
No.
only for certain use cases?
I would not exclude it, to be honest, because we would lose a lot of use cases for it, and then the big market of users, right?
Yeah. So
you would exclude them. This is not the way to go, right? But if you want to have real-time behavior, then of course you have to state somewhere, okay, if you use this kind of feature, don't expect that your system is really behaving in hard real time.
Yeah. Okay. Yeah. Just wanted to understand. Yeah. Thanks.
Previously, we had a long history using embedded, like we call it a Java compatible kind of embedded runtime.
You can go very far with it, I know.
Yeah.
If
There's no problem to build GC enabled runtime with a very tiny device.
Yeah.
So if you don't have a hard real-time kind of requirement.
You're right. You can go very far with it. However, you have to stick to some rules.
Yeah.
Otherwise, you will suffer a lot.
Yeah. Yeah. Definitely. Yeah. And maybe about the C ABI. Coming back to this, sorry for being a little bit jumpy, but I mean, if I look in a Rust project and I use the interaction with C code, for example, I can annotate my Rust structures and to be represented in a C ABI, which will give a hit on performance, a small hit, because like the Rust compiler sorts the struct in a certain way to get the highest performance in execution out of it. But you can enforce a C structuring of your struct, and therefore enforce a C ABI actually. And maybe this could be something to look into if there's a way to enforce it for at least the interface variables and structures.
Yeah, I'm also thinking about it in using legacy code. If you want to use legacy code, maybe some open source software that is outside in the world, most of them are using way down below somewhere some C runtime, anything, something, don't know what. And in not putting impediments on the users of using WebAssembly and the whole system, it would be nice not to force them to port legacy software or to rewrite it by any mean. So I think it would be good to have a kind of a compatibility layer or a concept of making it possible in using such software, such legacy software. I think that would help would make it much more appealing compared to when you have to first generate a WIT file and then use WIT bindgen, and maybe WIT bindgen doesn't work well, etc., etc. So this is a tooling question and an SDK question, which is obviously not easy to solve. However, I think it would boost the acceptance of using WebAssembly if you can say, okay, you can use 70%, 80% of legacy software out there, of libraries, etc.
Yeah.
I think what you both are getting at is today, most operating systems, this is the written in C.
Yeah.
Like, pretty much all of them. And this interoperability we're talking about has to happen between, say, making a kernel call, right? I need to pass a block of memory, and we're going to force a C structure across that barrier. And same thing with legacy code, right? If I'm interfacing to a library that was written for, say, OpenSSL, for example, and I need to pass a binary buffer, there's usually some sort of way I bring that across that barrier. And today that's generally a C struct, or C ABI to be more precise.
Yeah, or you have a C-like foreign function interface, like right, an extern C ABI, something like that.
Right, exactly.
Yeah.
That's like it's done today, right? And
Yeah.
I think the world is kind of used to it. Maybe this is good, maybe this is bad. I don't want to judge on that. But if you bring something new, like don't use a C ABI, don't use a wrapping of a C API, right? Just use WIT, and it's just good to do. But then you need working tooling, working SDK that the users can just use right out of the box.
Mm-hmm.
Yeah.
And as long as you don't have this, you must make it easy for the users in adopting to WebAssembly.
Yeah. And I think this was what I was proposing, kind of, that without touching the legacy code, by defining an interface in the WIT, you somehow magically compile this structure or whatever, this data which is transferred via the interface, to be represented in a C ABI. Maybe this just works for a subset of languages. Then we say, okay, we can have this zero copy only if you use C, CPP, Rust, and I don't know what.
Yeah.
But again, so let's say on the outside tooling, so actually doing the C ABI representation in a later step or at compilation. So you don't need to change your actually your input code. As you said, I want to use some legacy libraries where I don't want to touch each and every data what I'm sharing, but really doing it more like a post-processing step or an intermediate step, and taking a WIT or comparable interface description as an input for do the changes of the structure representation there. This was a little bit convoluted, but I think you got it.
So and this all relates kind of to the component model, the whole discussion, at least from my side.
Sorry.
Yeah, I don't think I
Yes.
understood that point either.
Yeah. Sorry, I did not fully get your answer, Thomas.
Just wanted to yeah, highlight that.
Okay.
I think the whole discussion relates to the component model discussion.
Okay, understood. Yeah.
I said it's not only a runtime topic; it's also an engineering topic, kind of, right? If you think about doing the implementation of a WebAssembly module is an engineering step.
Yes. Yes. Yes.
And so one thing I would ask everybody just for kind of clarity is, you know, if we look at modules versus components, right? Everything we're talking about here is compatible with the component model, right? I can do all these CABI things, and the component model is just fine, right? We don't touch that. Or sorry, we don't prevent that from being used, right? We don't change anything there. But the other direction is not true, right? Things in the component model wouldn't work if you don't support that stuff, right? So say if we say, hey, lifting and lowering is too much for these platforms, right? That's something that we can't do in, say, WAMR. So we're going to support the modules only, this CABI. So our code could run, say, in the cloud, but cloud code that runs with the component model would not be able to run here. And I think that's going to be one of the big hurdles we have to discuss and come to an agreement on. Is it? Am I understanding that correctly? That making sense to everybody?
To me, it makes sense, but I do not know whether the consequences is quite right. In terms of, is it really impossible to execute kind of components, or let's say components in WAMR? I thought it should be possible in doing so if you're able to unwrap kind of the component and pack it or treat it like a core WASI module. I thought that should be possible in principle. Maybe
I
the
believe
tooling
it
is not
is.
existing.
I believe it is. The one challenge is the lifting and the lowering. So I understand.
Right. If you combine it with Christoph Pettig's proposal or idea to put the lifting and lowering kind of into the module itself, then this could be solved. Or am I wrong?
You're referring to this one here, the ISRIX, or?
The discussion that we had a few minutes ago, where the responsibility of doing all this kind of mapping is to be shifted to the module itself or to the component itself, and not by a runtime.
Which kind of means to the SDK, right? Because you have to build it. So I think if you build something for the component model, you can't take that .wasm file and just load it up into WAMR, no matter what we do.
So I agree. I think because WAMR doesn't understand the component stuff, right? So it just wouldn't load. But I think what Thomas was saying is we could unwrap the component around that and make it a standard WASM module, which WAMR would be able to load. The challenge is at load time, yes.
Okay.
Well, actually, it doesn't have to be at load time. It could be well, yes, I guess it is at load time. I was like, you could do it ahead of time, right? If you wanted to deploy it to your device. Yeah. But effectively at load time. The challenge is that lifting and lowering, but you know, is there an opportunity or is there a way for us to put an adapter around that? So in those cases where I want to go do that, I have an adapter, but that adapter itself runs as a WASM module. So basically the flow would be, I take the component, I unwrap it to a module, and then I put in some sort of processing to do the lifting and lowering into effectively new methods that would get loaded into that module, and then that could run on, say, Whammer.
I like that idea. If I get it right, I like it.
I don't think I described it very clearly, but
Yeah, maybe I misinterpreted it. But what you're saying is you have another WebAssembly module that is also loaded more or less side by side with the unpacked component. So a core module, WASM core module that has been unpacked from a component, and you sideload kind of an adapter, which is maybe also loaded as a WASM core module, which does the data type transformation, right? That would make it very, very flexible. However, of course, with the impact of performance loss, that's all right. But if you make this very clear to the user, he knows this, and then he could by himself decide whether to recompile the source code that in the beginning was used to create the component, to recompile it as WASM core module without lifting and lowering, without the need of a side-loading WebAssembly who's doing the adaptation. Or he could decide just to use the component, having some kind of tools. The question is, from whom comes the adapter? So who's providing the adapter code? Maybe you can generate it. Maybe if you have WIT, the WIT file description for it, which you should have if you have the component. Then the user can decide: do I want to take the performance hit? Then that's all right. Just use the direct tooling, use the adapter. You're quite good to go, and you could use it for Whammer. Or you have to recompile it to a WASM core module without using an adapter, and make sure that all the data structures just fit together.
So let me replay that back to see if I understand. So I think one of the key ideas is if I have a WASI code, I should be able to run that. So say I have a WASI component and I want to run it on WASM time. Natively supports the WASI component model, P2, P3, whatever it is, has all the lifting and lowering optimized built into the runtime. That just runs, works perfect. Components can interoperate, do all that other fun stuff. However, I want to run that on, say, Whammer, which does not, at least today, support the component model. We could still take that exact same binary, unwrap the component to just a bare module, plus add some adapter code to support lifting and lowering where needed, and then load that resulting module, that module prime, and that would run on Whammer, at least in theory. Maybe at a performance hit, but I still have the compatibility is still preserved. Is that what you're echoing, Thomas?
Yeah, this would be my understanding, kind of. Yeah.
So I also thought about this. Sorry, Thomas.
Go on. Sorry.
Yeah. So if you have the WIT and you can generate this adapter module by this WIT, then you could add interpretation or understanding of Whammer to understand the syntax of the modules or of the component model, and then you could use dynamically add those adapters. But on the other hand, you could also some selected components you could add the native adapter. So I guess that most of the people here will not use JavaScript strings if they get edited sometimes. So you could just pretend that there is a polyfill from that based on the WebAssembly adapter. But if you have other things that are more commonly used, then you could add the native adapter to that and increase performance even more. And I'm also not sure if there actually is a performance hit, because if you do the adapter dynamic loading, that's the one thing. But on the other hand, if you unwrap the component, then it's basically the same, isn't it? Because you just add the corresponding WebAssembly code at compile time or by the SDK and not on load time. But when it comes to execution, it doesn't really matter in the end.
Yeah, the performance with performance hit, I mean, if you have to map data types. If you have to do this, then you have
Yeah,
somewhere a loop, something, right?
But-
You have to recopy something to another location whatsoever. This is what I mean
Okay.
with performance hit. I'm living in a world where mem copy is a very expensive operation.
Yeah, I know.
But I mean, even changing like byte endianness, you know, that is a
Yeah.
performance hit, right? It's
Right,
not a
right.
tremendous performance hit, but it is a hit, right?
Right.
And you assume that when you start from the source language, then there is better optimization where you can avoid this, because you have to translate the data type anyway.
Well, I think we're going from same language to same language. I think we can skip that because it's the same on both sides. I think that's the comment.
Right. If you have different languages, then yeah, of course, you need some mapping, most likely.
Yeah, okay.
Let me just replay back what you, since I'm the note taker, I have to get this right. Max, what you're saying is there's probably some common lifting and lowering conversions that might be in use. This world, as you said, is probably not using JavaScript, but there may be some list to array, list to linked list, something like that. That is done very, very often. And so therefore, what we could do is a runtime could selectively implement some of that in native code, potentially optimized, and kind of get a middle ground here where that adapter could be maybe an adapter isn't needed because WAMR understands enough of these lifting and lowering conversions. So just unwrapping the component to a module is sufficient. Is that what you're saying?
Yeah.
Okay.
Yep.
Yeah, I think everybody's trying to process that conversation.
I'm still trying to put it into perspective.
Yeah, I'm doing the same.
Yeah. And so sorry, I somehow missed the shift from getting rid of lifting and lowering and now having an adapter. So this
No. So it's exactly the same, Dominic.
Mhm.
So say I want to run a component on WAMR, which doesn't support the component
Yeah,
model. We'd have to unwrap it to a module. And then for any operations that require lifting and lowering, something needs to implement that lifting and lowering. One option would be to have WebAssembly code that is an adapter that can do those lifting and lowering. What Max said is, hey, that's possible, but the runtime could also provide that adapter, right? And so if there's a set of common things that we see in the interfaces that we want to support, something like WAMR could choose to implement that adapter in the runtime rather than having to put the adapter on dynamically.
Okay. Yeah. Understood. Okay.
And I think also, yeah, just wanted to add, if just presuming that these adapters can get generated automatically, then you don't have the implementation overhead. You just, if you need it, you can add this native implementation, and if you don't need it, you just can use the WebAssembly runnable adapter that falls out of the WIT generation.
Yeah, if you can just generate it, that would be great, of course.
Is there any reason why we wouldn't be able to generate it?
I think this should be one of the design goals, to have it that you can generate it. I think that's one of the requirements.
Yeah, I mean, if you think about, we do this in WIT and we define lifting and lowering so that the runtime can do this dynamically. So if the runtime can do this dynamically, I'm assuming we could just generate that code, should it be needed. So it's okay. Yeah.
Me too.
Yeah, so if the runtime could generate it kind of maybe during load time, well, could be a thing. That would mean that parts of with bindgen go into WAMR. Got it? Did I get it right?
Well,
So-
if you did that, then it would basically be implementing that part of the component model support in the runtime. So I don't think we'd want to do that. But I think what's being proposed is we could say, say, hey, WASI P4, there's all these components that we support. We could generate all those adapters, right? And it could be that, and that is all WebAssembly code that could be used where needed. I think what Max is proposing is, the WAMR team could be like, hey, listen, these 3 adapters here are used in all these components. So it's a common adapter. Rather than use the WebAssembly version, I'm just going to build that routine directly into the runtime and do that and optimize that, right?
Yeah, got it.
For random component that comes out, right, from third party, right, that probably is not possible unless they're using a well-known conversion already, right? We'd have to generate those because it'd be something that's not known, for example, a priori.
Yeah, so my idea is basically that you can fine-tune your own runtime if you know what you will probably execute. So the other adapters just have to be there on some kind of magic way. But yeah, just if you know that one operation will be reused very many times, then you can add that to your WAMR implementation.
If you could come up with a consistent way to identify that mapping from type A to type B, then you could come up with either a method name or a adapter name, and then that would be consistent. So if that's used in more than one place, it would effectively map to the same adapter name.
But isn't that done by WIT already? So we have their...
Probably.
Yeah, okay.
Alrighty.
Liang got a question in the chat.
Oh, sorry. Adapter won't be necessary, right?
Not necessarily. So I think it depends on what's inside the WASI P2 kind of core WebAssembly module. I think that is what you're referring to, Liang.
Yeah, you're right.
So yeah, if I understand this correctly, I have a WASM component. It has a method called foo that takes a parameter. I can unwrap that component to a WASI module, but that parameter going in and out of 2 different languages is what we're talking about potentially needing an adapter for. One solution is to say, no, that parameter has to be a CABI, and that's used by everybody else, and we just all agree on that. The other option is to do the component model where you've got the lifting and lowering. And so we're proposing a third where, like, hey, if you wanted to run that and it wasn't using that CABI, then you'd need to provide an adapter.
Yes, you're right.
And the question is, where does the adapter come from? And this has been discussed, kind of ideas about it. Where does it come from? Whether you can generate it or whether you can provide some, let's say, very common adapters directly in WAMR in an optimized way. I think this can be discussed, and I think this would, to me, this sounds like a good way to go forward.
Yes.
In the second case you just mentioned, I mean, the multi-language. At this time, the lowering and the lifting we are talking about is about translate typing between the guest language type to WASM word type, right?
That's my
It's not
understanding.
about just WASM spec type to component high-level type, right? Because there are 2 type translation. One is from the guest language to WASM word. Usually it's a WASM yeah, it's usually a spec WASM type. The second one is, between the lower and lifting the WASM type to WASM spec type. I mean, the four basically type I32, I64, blah, 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 to the component type, like the recorder list or string, something like that. And in the multi-language world, we cannot avoid the guest language, different guest language type to the union WASM type, but we can avoid somehow, the I don't know, WASM basic type to component type. Is this what we are thinking?
So you're referring to transformation of the kind of types that you're using in the host and the types that is used in the WebAssembly world?
Yeah.
So kind of,
Yes.
let's say you have I'm coming from LLVM IR, right? So you're coming from an I8, right? So an integer 8-bit, and you map it to an, don't know, int 16 in the web, or I32 in the WebAssembly world, right?
Yeah, I32 Europe.
Could be one mapping, and this needs to be done by any ways, right? Because we're talking about WebAssembly.
Yeah, this is about only one language, but if there are multiple languages, you might upgrade the I8 from the guest language to a component type. Maybe, I'm not sure what it is, a char or byte or something. And then you have to lowering it to the I32. There will be two things, two
Gotcha.
times. Yeah. So I think we can maybe, to simplify the whole story, because we are in the embedded world. Maybe we can think there will be only one, a few languages which can share the CEBI. So there will be no guest language type to the to what? No.
I'm not sure if we need the mapping from a WebAssembly type to a component type once you have unwrapped the component to a core WebAssembly module and providing some adapter code that is just adapting the type information from one language into another language. So why do we need a map to the component's type once we have unwrapped it? That's what I do not get.
If there are multi languages, then we might need that part, because if even it's a string, it will be different representation in C, in Rust, or in Java, right? But yeah, but if there's no but. Sorry.
Yes, you have this different representation in the different language, right? And that's why you need to have these kind of adapters.
Adapter is for per language, right?
In my understanding, an adapter is something that provides some code, basically, that maps a representation of a data type or of a value in the memory that is represented by a data type to a value that is represented to the corresponding data type in the other language. Call it a cast.
Yeah.
Or call it a pointer cast.
Right, but I think that the point is, in the component model, there are more complex types, right? So I might have a list of string, right? And then I pass a list of string to some method. Well, what is that? That needs to be converted to some sort of WASM type. And then on the other side, that needs to be converted from, so it needs to be converted from, say, Go to WASM types. And on the other side, I have to convert those same WASM types back to whatever the representation is in Rust. So there's actually an adapter on either side of that. If you're going from component to module, from a component to a component.
Yeah. So sorry, guys. I love the energy and I love the discussion, but I have to leave, which will stop the recording. So
Okay.
I think we're over time already.
Yeah.
And I think I would even close the meeting if I leave right now.
Yeah, I think this is a good discussion. Should we just earmark this for continue this next time?
Yes. So really loved it and really cool discussion. And this is really getting some action right now. It was a really cool meeting. Thanks for everyone, to everyone for sharing your thoughts. And thanks, Stephen, for doing the notes. And I will take care of the YouTube upload. And sorry, Thomas.
I would propose to continue on that with the next meetings. So
yes, definitely.
Perfect. I got that in the notes, so we're good.
Awesome. Cool. It was really cool. Again, thanks to all. See you around. See you in 2 weeks, and take care.
Yep. Thanks, everyone. Appreciate it.
2 weeks is
Bye.
the WASMCon.
Yes.
Maybe we will not have a meeting, but we see each other there. So
I will be there.
Looking forward to it.
Awesome. Cool. See you all.
All right.
Bye, guys.
Cheers.
Bye.
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 Bye.